Okay, let's look at question number 21. So I have drawn this the payoffs in the tree diagram for this particular question. We have to find the number of Nash equilibrium. So let us construct the strategies. So the strategy profile for player 1 is going to be 4 options. Either he chooses LL at every position. Yeah, either he chooses L everywhere, that is he picks L here and L here. So there are two decision nodes of player 1 and he can pick L or right, left or right everywhere. So LL is one option, LR is another option, RL is another option, and RR is the final option. So this is player 1. Then player 2, for player 2 we will have these two options. So player 2's options are just up and down. Okay. Now if player 1 chooses left in the first instance, the game ends here no matter what happens after this. So the payoffs everywhere are going to be 1, 0. Okay. After this, if player 1 chooses right and player 2 chooses up, alright, so in that case the game always ends here at 0, 2. So right and up, so right chosen by player 1 and then up chosen by player 2, so that's 0, 2. Alright, then 4, 0 is going to be right, down, left, so that's right, down, left, so that's 4, 0. And finally 3, 3 is going to be right, down, right, so right followed by down followed by right, so that is my 3, 3. So let us look at the Nash equilibria for this particular sort of game. So if I fix the strategy of this guy as up, as playing up, then the best response for this guy is 1, and if I fix it as down, then the best response is 4. Okay, and then when I fix this guy's strategy as row 1, player 1 strategy is LL, then both of them are best responses. If I pick it as LR, then again both of them are best responses, right? If I put it as this, then the best response for player 2 is 2, and if I put player's 1 strategy as RR, then the best response for this guy is down. Best response for second player is down. So as you can see, there are two cells in which both the numbers are highlighted or star marked or circled, and so there are two Nash equilibria. So the two Nash equilibria are LL comma U and LR comma U. So these are the two Nash equilibria. So they only ask the Nash equilibria in pure strategy. So there are two Nash equilibria in pure strategy. Now what they do not ask, this is a deviation from all the previous years, is in the previous year they would have asked find a subgame perfect Nash equilibria. So the subgame perfect Nash equilibria out of these two Nash equilibria is the one which is perfect in every subgame. So if I look at this subgame, if I were to focus on this subgame and what happens here, because this is essentially the difference between these two strategies. The strategy difference is here, what player 2 does, player 1 does in this node. Now what should player 1 do if the game reaches this node is that he should play L, because L gives him a higher payoff of 4, whereas R gives him a lower payoff of 3. So the subgame perfect Nash equilibrium is L comma U. So this is only 1. but this is something that they do not ask. Okay, so we were not asked for subgame perfect Nash equilibrium, and that's why we do not report it. Right, so the correct answer here is 2 Nash equilibria, and that's option number B.